What's up, everybody? Welcome back to another video about limits. I think this is like number 3 or something. And in today's video, I figured I would show you guys some rules of limits. So we went over pretty much what a limit is. We went over how to use limits, kind of what they symbolize. But as we approach more complex problems, right? As we approach more difficult problems, we're gonna have to use some tricks, little tricks that we can use here. So let me go ahead and show you some rules that we have when we use these problems, and then I can show you some problems that we can practice them for. All right. So let's start off with our first rule. What the? Alright. You know, this thing is cool. I love my writing pad. But sometimes... Alright, there we go. Now we're talking. Alright, so the first rule we're going to talk about is what happens when we take the limit of a sum, the summation of two functions, right? So we're going to look at it. Here's a generalized thing. Don't let this scare you. It's going to be the limit as x approaches some number, right? And we're going to say, what if we take the sum of the function f of x plus the function g of x? What happens if we take the limit of two functions like that, sum together? So this is just going to end up being the limit as the first function approaches a plus the limit as the second function approaches a. Nothing crazy there. Nothing spectacular. We didn't cure world hunger. We didn't cure cancer, but we're making strides to eventually do it. Right? Let's go to number 2. And then after we do them, I figured then I can show you the rules of which we can use them. The next one is like the same thing, right? It's just nothing special here. If we take f of x and we subtract g of x, so we take the difference of two functions, take a guess of what we're going to get. Please don't get this wrong, because it's the same thing as what we already have, right? Okay, so what's that saying? It's saying if we have a combination of two functions, if we have a difference of two functions, we can separate the two functions out. So don't be scared, guys. Separate those functions out, and then take the limit of each function independently of each other. Not bad, not bad. Let's move on, because this is when things start to look a little cool here. Let's go to number 3. Now, they don't really. I just want to keep you guys entertained. We're going to take the limit. We take the limit as x approaches some number. This is not a 0, so let me make sure. That's an a. Of a function. Right? But if we take that function and multiply it by a constant c, take a guess of what that becomes. Remember, this constant right here, this is not in terms of x, right? C is not in terms of x. So our limit of a constant, not in terms of x, shouldn't really affect it. It shouldn't affect it. So if we pull it out and then just multiply the actual limit by it, we should get the same thing, right? So this is saying if we have a function multiplied by a constant, and we're taking the limit of that, that's no difference of taking the limit of just a function and then applying it, and then multiplying it by whatever constant is multiplied. So, yeah, that's cool. Don't overlook that one. That one might come back and bite you in the ass if you overlook it. Let's look at the next one. Let's look what happens if we take the limit of what happens if we multiply two functions together, right? what if we say we're going to multiply f of x and g of x together? Nothing crazy here, right? I'm going to take the limit of the first one, take the limit as x approaches a of f of x, and then, what do you think? Dun 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 dun. Yes. Yes, if you said the right answer. No, if you said the wrong answer. You multiply the two limits together, okay? So, that means if we look at our function, we're going to do some practice on these. Really, really, don't get scared. Because this is all like, oh my god, what's f of x, what's g of x, whatever. If we take a function and we can break it up into two unique functions, if we take a function and break it up into two unique functions, then we can apply these type of rules. So if we say we can take a summation of two unique functions, a difference of two unique functions, a function multiplied by a constant value, or two unique functions multiplied together, we can apply these rules. One last rule, okay? Because I don't know if you had the spinning now. So get a glass of water if you're not feeling too well. So it's not on my conscience. What is this? What's my thing? But for the last one, we did addition and subtraction, so we might as well do multiplication and then division. So if we divide two functions, right? Obviously. Now you're pro at this. We know that it's simply the limit as the, I'm thinking about this, they don't make it too easy to erase. We take the limit as the numerator approaches 0, and then we take the limit as the denominator. Did I say 0? I'm sorry. I meant the limit as the numerator approaches a, and the limit as the denominator approaches a, and that's what we get. So I did this in different colors. This is scary looking, right? So, but it's not bad. Let me draw lines in between each one of them so you can see the difference. Whoa, that's not what I anticipated happening. As you can see, I am not an artist, and if I were an artist, I certainly won't have straight lines in my art. Okay, so summation of two functions, subtraction of two functions. We're gonna call this the stuck of words here. We're going to say if we magnification of a function, right? Or of course c could be a ratio. It could be 1 over something, it could be 2 over something, it could be a fraction. So this could also be the attenuation of a function. The multiplication of two functions and the division of two functions. So here are our 5 limit rules. 5 limit rules. Okay, so let me stop here for this video, and then next video we can see how these limit rules can apply to real problems. Thanks for watching, everybody.